Good morning, good evening, good afternoon, and thank you for joining Neo4j Live today on the 9th of January. So I guess it's still good to say Happy New Year. Hi, Phil. How's it going?
It's going great, Alexander. Happy New Year.
Happy New Year indeed. Yes, thank you very much for joining, Phil, today. Phil Meredith, you are the CEO of a company called ProcessTempo. And you submitted to a Notes 2023, but unfortunately, due to all the submissions, not only one, but a few of the submitted talks couldn't be put into the agenda. And so I reached out after Notes, and we said, hey, let's make it work. And this is one of those sessions. That is now coming in after Notes as one of these live streams. So I'm very happy to have you today to join in and to present what you want to present during Notes earlier, or not earlier this year. Obviously, this year is just started, but late last year. And now I'm happy to have you here today to talk about unique graph use cases for risk reduction and improved bottom line. So sounds like a good topic to start the year, especially when you are wondering still how do I apply this graph database I heard so much about. What do I do with graphs? What to do with all these things that everybody talks about these days? And maybe one of your New Year's resolution is to try new technology, and maybe it is graph technology, and you wanted to know what's what. So I think this is a good kickoff episode. So I'm looking forward to this very much. So I'm happy to have you here today. Thank you very much for joining, Phil.
Yeah, thanks for the opportunity. For the Nodes presentation, I really just wanted to talk about the art of the possible. I think a lot of people kind of go into using a graph for a very specific use case or problem or challenge, and they zero in on it, and they maybe they find success, and now it's like, what else can we do with it? And that's kind of what I wanted to cover, all these exciting new use cases that the graph can provide.
Yeah, I think that's a good point, and I guess we're going to talk about this later a little bit as well. It's like when you hear about graphs, a couple of use cases come to mind immediately, and you think, okay, this is what you do, and then you go that path and think, okay, yeah, this makes sense, and then you don't think about other ways of applying it. And then if you talk to people, if people that are especially use it a little bit more, who are a little bit more experienced, realize, oh yeah, actually you're right, there's another one, and hey, there's this one as well, and oh yeah, this one.
Mm-hmm.
So it's quite versatile, and not only social networks, if you might think of the most common one that people immediately think, and it actually is not the most common one we see at Neo4j. So it's not the most application for us at our customers is not a social network. So
I have a few slides to share, and have a little bit of demos to kind of back up some of the use cases we've been talking about. Should I jump in?
Yeah, let's get that ready. As always, this is obviously live and interactive. So if you watch this live,
Right.
if you have any questions, any feedback, let us know. If you are using graph databases Neo4j already now, and want to share a little bit, this is also a great way of doing that. Use the chat. We'll have some time at the end, obviously, to do a Q&A. And we can discuss a bit of use cases and applications. So would be nice to see that stream of interactivity going. But for now, I think we can dive in. And honestly, I don't remember. Maybe Phil, should we? I mean, I said a few words about yourself, but maybe do you wanna kick off by introducing yourself properly?
Okay, sure.
Yeah.
I mean, I do have a slide, but
Yeah,
whatever.
let's use that. Yeah, we can use that slide as well. Yeah, that's
Well,
totally
yeah,
cool.
so I'll share
Yeah.
some slides, but before I start, I'm wearing this shirt on purpose today because last night the University of Michigan football team won the national championship.
Oh, nice. That's cool.
Yeah,
Oh,
it's
cool.
my favorite team. So shout out to all the Michigan fans.
Cool.
Some
Congrats.
people are
Yeah.
probably happy, some maybe not so happy, but that's how it goes with sports. So
Yeah.
I had to wear this shirt. All right, I'm going to share my screen. And which screen do I share? Let's see here. All right, let me know if you can see my slide.
Yeah, here it is. I'll put
right.
the banner out of the way. Here we go. And maybe do it like this, so it's not on top of things. Yeah, this looks good.
Yeah, so hello, Phil Meredith from Fort Lauderdale, Florida, founder and CEO of ProcessTempo. That's my LinkedIn QR code. If you can see it on the screen, and my email address is there. It's phil.meredith@processtempo.com. Please connect, please reach out. We have been on, the company has been on this journey with Neo4j for quite some time. We were actually founded in 2016.
Mm-hmm.
And at that time, I think Neo4j was around version 1. So we were early adopters of the
Could
graph.
be, yeah, 2016. Yeah, maybe it was already 2. I don't know,
Okay.
20. Yeah, maybe, but it's still, you know,
So yeah, right. So maybe
long way away from version 5, which we're currently at. Yeah.
Yeah, it was the early days.
Yes. Yeah.
Early days. I think we were tinkering with some prototypes prior to being founded. So even maybe 2015 timeframe. It was very early. I just having had a background in data and analytics and standing up enterprise data warehouses. To stand up a data warehouse, there's a lot of engineering effort that goes into it, where you have to define the schema, define the primary keys, foreign keys, all of that, right? Figure out joins, and there's a lot of engineering work that goes into standing up a data warehouse before you even put a single row of data into it. When I saw Neo4j in the graph, I really loved the property graph model, the asset compliance, the flexibility that it provides. And I recognize that Neo4j would be a great alternative as an enterprise data warehouse because of its flexible nature. Now, certainly very appealing was the kind of social network aspect that you discussed, right? The ability to capture these relationships. But we saw it really as an alternative, a flexible medium to start landing data in for a variety of use cases. And I had seen this in the enterprise space throughout my career, where an organization would stand up this massive enterprise data warehouse, but it would be very inflexible. And as requirements change, users will start building these operational data stores or these mini data warehouses, and it just gets really complex, crazy. And I thought, hey, what if we could just, instead of creating a new operational data store, we just add more nodes to the graph to fit this specific use case. And so it's worked. It's worked really well for us. So I'm going to talk about ProcessTempo, the platform itself. And all of these use cases here, we're not going to have time. I don't want to go through all of them. But if you could take a mental image of these use cases and maybe ask questions about them, or hit me up after the live event. We have experience as our organization implementing all of these use cases for enterprise customers, where the foundational component is Neo4j. So supply chain control towers, global data catalogs, recommendation engines, software bills and materials. We have hands-on experience delivering these for our clients, all based on the graph. I want to focus, and of course, I can take this conversation anywhere, Alexander, and if anyone pipes up, but I have a lot of material on these 6 specific use cases that we'll talk about. Spreadsheet replacement, supply chain control towers, cybersecurity analytics, spend leakage, global data catalogs, and I want to demo our new Gen AI acceleration. I know that's a hot topic.
Yes.
So we're gonna go into that. So yeah, I want to spend a few minutes on each of these use cases and then show a demonstration. Does that sound good?
Yeah, sounds very good. Yes, cool. That's good mix of topics, I'd say. So yeah, I think I'm happy with that. But again, if somebody, like you said, if somebody in chat has something else to discuss, or wants something to know, wants to know something, then just let us know.
Let us know. Yeah. Okay. I'm in full screen mode, so I can't see the chat window. So I'll let
I'll watch.
Okay. So I need to educate you, the group here on the call, a little bit about ProcessTempo. What we've done is we've taken the graph as this foundational data warehouse technology, and built on top of it self-service analytics, which is basically dashboarding, right? And but it's dashboarding that's really kind of easy to use versus tools like Power BI or Tableau, which require a certain level of training. And then with the dashboards, we've added embedded forms and workflow. Now we call ourselves the Neo4j Graph Application Accelerator. And what that means is with these two features on top of the graph, we can build data-driven applications without writing code, and we can accelerate the delivery of solutions on the graph. So when you say the word dashboards, people think, oh, you're a dashboarding tool. And I say, no, we're really a rapid application development environment that natively supports the Neo4j data capabilities. And we provide this in one kind of integrated platform. And we go into environments where there's just a whole, enterprise environments where there's all kinds of tools, right? All kinds of different database technologies, all kinds of different dashboarding tools and solutions, workflow. And what happens is when somebody buys a license of Neo4j, they're going to want to build an application on top of the database. And so they're going to have to go out and get all these tools and bring them together themselves. That takes time. There's a lot of risk. There's a lot of integration, a lot of moving parts. With us, it's just kind of one platform, and we can kind of bring it in together very quickly. And the time to value is compressed when it comes to benefiting from the graph. And that's our main value proposition, is we want to accelerate the implementation of graph use cases by minimizing the moving parts and getting to that use case that works for you as quickly as possible. This is just a graphic of how we would deploy. We would deploy this capability next to Neo4j within the client's private cloud. And we would help that client move the data into Neo4j and take advantage of our technology. But this is supposed to be kind of an architecture footprint, kind of where we sit in the environment. Does this make sense to you?
Mm-hmm. Yep.
Cool.
Yep.
Okay, just one more foundational piece before I go into the use cases. And this is, like I said, the integration of the dashboards and the workflow. So on the left-hand side of the screen, you have an analyst looking at data that's in Neo4j, and we're representing that data in the dashboard. And like any database, right, Neo4j is only as good as the data that is stored in it. So if the analyst is finding something that's wrong, they could actually click a button, open up a form, and try to solve that problem right then and there from the dashboard. So we integrate forms and dashboards together. It's kind of neat. Mm-hmm. So that form, when the user clicks submit, that could write back to the graph, right? It can create a node or a relationship or edit one or delete one, right? Mm-hmm. Or it could call an API and take that data and pass it to an API or a third-party system. And so in that way, we're fixing the problem at the source, potentially. If we don't want to fix things immediately, sometimes you want to have a workflow. What that can also do is kick off a workflow where it puts this item in somebody's queue. And that's the gentleman on the right. He's got this work queue and it's prioritized, and he sees that there's a problem. Now the gentleman on the right can react to it and can address it. And there's that whole audit trail and history of this happening. Mm-hmm. And all this is metadata stored in Neo4j. So that's just a little background, forms and dashboard. And that's how we're really able to kind of go after a bunch of these different use cases. And why we have such success working with Neo4j and delivering on them, because we're not, like I said earlier, doing all kinds of engineering up front to make this happen. We're diving in and solving this problem. One of the first potentials I saw for the property graph model was, this is perfect for spreadsheet replacement. I was at a meeting at JP Morgan Chase, and they're in a meeting, and they were trying to solve a compliance issue. and they were all in this big room, and everyone had their spreadsheets, and they couldn't fit things together because there was no collaboration or consistency across spreadsheets. And I'm like, I've seen this so many times. In fact, JP Morgan was in the news in 2012, $6 billion loss because they were copying and pasting data across spreadsheets. I mean, it's mind boggling, right?
No, that doesn't sound like a good idea.
Yeah, Fidelity put a minus sign instead of a plus sign, and it was a $1.3 billion swing. And it was they reported a gain because they forgot the minus sign when it in fact was a loss. So I mean, these are significant things, right? I actually wrote a blog about this on LinkedIn this morning about how dangerous spreadsheets are to organizations.
Mm-hmm.
And what happens is people or they go to IT and they say, "Hey, we have this new business process we need to implement." And IT says, "Well, we would have to customize our backend systems." And that's sometimes, you don't want to go there. So they'll say, "Well, we'll just implement this in a spreadsheet." And so they'll start filling information into a spreadsheet. They'll pass the spreadsheet around to different people who also put in their knowledge. And all it takes is one person to put in the wrong value, and that suddenly persists and becomes the truth.
Yeah.
Right. I don't know if you've had any stories or experience.
Yeah, yes, something like that is another partner of ours who's called Andreas Weber here in Germany, and he says he knows oftentimes when he goes to companies that he tells the story that everybody has their little Excel kingdoms set up. So everybody has their own, they have the company has technically a perfectly working infrastructure of tools and everything, but everybody has their own whatever Excel file they also maintain on the side, kind of with their knowledge, with their things. I guess a little bit about fearing of being redundant a little bit, but also maybe tools are not as user friendly as they could be, and then it makes sense to start with an Excel sheet, and then as you just described, it grows into something huge, and at some point you realize, oh my god, this was once a little crook on the side for helping out things, is now becoming this huge behemoth of thousands of lines, and nobody knows what's going on anymore. And it's crazy. And then how do you get the data back into the system? How do you actually make use of it? Because these files are not compatible with each other. Everybody calls things differently. It's a mess very, very quickly, and not very, very helpful for anybody. Nobody is benefiting from it, I think, at some point.
It's amazing now. So spreadsheets are kind of like they fit that gap between enterprise applications where these applications are inflexible. They still need a little place to put this data and knowledge, and so they squeeze it between these applications. Really,
Yeah.
is what happens. Kind of the glue that binds things together is the spreadsheet, and
Yeah.
every large organization effectively runs on spreadsheets, despite tens of millions of dollars in IT investment. It's scary. So this, I think, is a great place for Neo4j because you think about it, this is each cell is kind of like a node potentially, and the cell next to it is a relationship, and each sheet or tab that you add to the spreadsheet is like another node category, and they're all formulas. You can translate that in your mind to the graph, and that's kind of what we've done. We think of a spreadsheet as kind of a mini application. It's got its own interface. It captures data. There's logic in it. We're trying to provide features to swap that out. So ProcessTempo provides the interface, the data capture. The graph is the storage mechanism. And we also provide an audit trail, which is also missing from these spreadsheets, is when somebody enters something and fixes something, there's not always a clear understanding of who did what down the road,
Yeah.
right?
Yeah. And I think that's very helpful because like I said earlier, you can imagine if you have 5 people at a company creating their own Excel sheets, you probably have 5 different terms for the same thing, sitting there, and then it's like, okay, we all mean the same thing, but we call it slightly different, and then it becomes very confusing and very, very difficult to follow through. So this is a very important feature, I think, for the just for data clearance and for data usability at some point, because it's messy.
Right. And so for our audience today, if you simply just do an inventory or suggest that you do an inventory of all the spreadsheets being used, that could generate some interest in developing a strategy to replace them. What's your strategy? Because there's a lot of risk involved. Maybe we can port that logic and data to the graph and save the organization potentially billions of dollars by implementing these solutions a proper way using Neo4j and not in the spreadsheets.
And helping out every user with it as well. I mean, I don't think anybody really likes to use these spreadsheets. I mean, with the exception of a couple of people who are really the masters of tables, but the majority use it, they use it because it's the next best thing they can kind of use and control. But if you offer them something that is just slightly better, even slightly better, then people will flock to it. And I think what you just described is not just slightly, but usually better and helps a lot.
Right, exactly. So I think this is low-hanging fruit, right? To consider. I mean, this fits every large organization. The next use case I want to jump into is supply chain control towers. And we have a number of customers that are in the automotive and manufacturing space, and this use case is very important to them. My first question to you and the audience is: do you guys know what the term supply chain control towers means?
So I do not. So maybe we explain. I know what a supply chain is. I know what a control tower is, but I haven't heard the term in combination. So
Okay.
Let's hear an explanation.
Yeah. So a control tower, like at an airport, right? Make sure the planes are coming in safely and routed to the right gates safely. But sometimes something happens, right? Maybe a plane is stuck on the runway, or maybe there's traffic backed up. The person in the control tower can see that visibly and then can take steps to make changes that divert the planes to either other gates or other runways or that sort of thing. So it's really ability to see a problem and then take steps to kind of fix it. And in the supply chain, we need that level of visibility and control, because without it, nothing happens, right? A shipment backs up in a given port and nobody knows about it for a few days, or maybe one person knows about it and is ringing the bell saying, hey, we have a problem, but they can't take action, or they don't know who's responsible for taking action. So what happens is there's a delay. And in the supply chain, the delay is like a domino effect. It can knock over a bunch of dominoes downstream, and the root cause may not be apparent to that last domino. The person owning that last step could say, "Oh, something broke. Why is it?" And in retrospect, we can look back at what happened, say, "Oh, well, because the ships were backed up in the port, or because there was a trucking strike, or because this assembly line went down for 6 hours, or the supplier ran out of these ingredients," right? So if you think about it, that's a graph, right? All those things are integrated and dependent on each other. And so what we try to do is cast light on those supply chain dependencies, and then enable the different people at different parts of the supply chain the power to make changes, the power to divert or to accelerate or expedite or that sort of thing. And by empowering these different users at different levels of the supply chain, we can react to problems much faster, and the supply chain operates with greater resiliency. So that's what we talk about when we implement supply chain control towers. So here's an example. This is a real world update. Unfortunately, it just happened the other day. There was an event at the port in Houston, and what we could do, and what some of our customers are doing, is they're tracking these events and creating nodes in Neo4j for each event, and they're using natural language processing to extract from that text. This is the port of Houston in Texas in the United States, and it had this event, right? Mm-hmm. And if we add that event to the graph, we could potentially now link it to different parts of our supply chain. So we're creating a digital twin of the supply chain about what plants and products, materials, locations, and now we're adding news events. And now we can quickly say, oh, wait a second. Okay, because the Port of Houston, there might be a problem with this particular product, right? We could see the dependency. And on the right here is a screenshot of an example of our supplier scenario modeling. There's an image of the graph. And what I'm trying to depict here in this image is that this is a key hub. All these lines connect to it. And we don't have an alternative. We don't have a place to reroute it. So that becomes like either a bottleneck or a point of potential failure that we want to duplicate. So the idea is now users change policies or make changes with the ProcessTempo forms. And then now the picture on the bottom right shows that now we can reroute things to different locations to address this particular event in our supply chain. So I'm trying to simplify this for our audience here, but it's a combination of building the digital twin, capturing events, and being able to identify potential bottlenecks or issues before things happen.
Yeah. I mean that's very important and crucial for many things. I mean, you don't wanna be the person at the end of the line that's waiting for their delivery and thinks, okay, it's gonna come tomorrow, and then it comes not for another 5 days or so. Then you're wondering why is that, and nobody tells you about it. But if you the least thing you can do nowadays is, I guess, tell your customer, say, hey, sorry, there's an issue, your shipment will be late. But the best thing obviously would be to do, hey, we know we can change course of the shipment and say, okay, don't go to Port of Houston because it's clogged. Go to Port of, I don't know, somewhere in the area that is available, and reroute your shipment and change your and change the delivery, so to be, maybe we won't be on time, but we will be maybe a day or two late instead of a week or even longer.
Yeah, and if you're responsible for that at that level of supply chain, having this level of visibility is a must, right? And they do have certain level of visibility, but the power of the digital twin allows them again to see several steps down, or vice versa, right? Back and forth through the supply chain. And now I know what products, what people, what plants, what manufacturing lines all impacted by this. And furthermore, now that the data is in here, we could use the graph data science algorithms to look for patterns. For example, I want to look for scenarios where I have kind of a single point of failure in my graph or in my digital twin, my supply chain. So where are my single points of failure? And let me go in and immediately start addressing that before something happens.
Absolutely. Yeah. And it's I think it's very important, and especially looking at this in almost real time is a great benefit. And I know of many companies who are struggling. There's this one customer of ours that were dealing with the same issue, and they were saying, hey, what can we do, and what's our supply chain scenario? And then the department said, well, give us a couple of weeks so we can assess what's going on. So that's like, that's not an answer. I mean, if you need 2 or 3 weeks to calculate or to showcase the current scenario of supply chain, then this is, it's not going to be good enough.
They call it turning the Titanic.
Yeah.
Got to turn the Titanic, right?
Yes.
I encourage our audience to kind of think of all these micro decisions that happen on a daily basis, not necessarily the big decisions that we need to turn the Titanic. What about all the little micro decisions that if we had easier access to this information and easier understanding of dependencies, and we can offer it to everyone responsible, both technical and non-technical users, right? Simpler access. Imagine how quickly we can make these smarter, data-driven micro decisions on a daily basis, and that combined can squeeze a lot of inefficiency out of the supply chain. Okay, moving right along. I like the pace. We're going to jump into cybersecurity analytics. Basically, what we built for a couple of our clients actually is this concept of an API catalog. Now, these organizations have their own software development teams, and these software development teams are racing to produce the next great release, right? The Neo4j development team, like the ProcessTempo development team, are always under a lot of pressure, aren't they? Got to get that next great release out and make our customers happy and stay competitive, right? We have a large automotive customer who built a large application, this massive application that basically allows the customers, the owners of these vehicles, to use their phone and unlock their car or start their engine or turn the heat on or something like that, right? All cars are capable of doing this today, aren't they? Most of them anyway.
Well, modern car, yeah.
Now think about this. Like you have your children with you and you have your arms full of groceries. You just come out of the store and you got your phone and you're trying to unlock your car and it's not unlocking. And your ice cream is melting and your kids are crying. And what's in your phone? And it's not. So you go right on Twitter and you tell Twitter how much you hate your new car, right? That's these automotive manufacturers' worst nightmare, is that scenario. And it's happened a couple times where users have been locked out of their car or their app is no longer working and they get frustrated. And that frustration is evident online now, right? So they spend lots of money trying to solve this problem. So what we've done is the API is the glue between all of these microservices and applications, right? The API is also the #1 attack surface for hackers. And what hackers do is they know that these APIs exist. They know how these APIs work, at least with posts and gets and that sort of thing. And they try to exploit them. And when they exploit them, they can now shut down servers, add logic. They can do scary stuff, right? And troubleshooting, just outside of being hacked, just troubleshooting a bug can be a challenge. And the idea is that let's create a digital twin of your software development world, your APIs, your applications, any dependencies, gateways, owners, and let's build a catalog of these things and let's assess their cybersecurity risk. And again, this is low-hanging fruit. We can walk in and do this very quickly, and it's eye-opening. So some of our customers thought they had, I'll just put a low number because let's just say 500 APIs. And we would say, no, you have 5x that amount. Right? Like, what? Yeah, no, you have 2,500 APIs. So I'm not going to use real numbers because I'm under non-disclosure, but that's the magnitude of it can be eye-opening.
Yes. Yeah, I can imagine.
Right? So these are screenshots of dashboards and forms we built to fix this problem. But I think building this graph could be eye-opening for your organization. And I added that dependency node there with dotted lines because that's really not in scope for an API security program. It sort of is, but if you add these like library dependencies, you suddenly can now build a software bill of materials. So it solves multiple problems. And when the the Log4j bug came out, having a digital twin of this environment, you could just go in and go, where do we use this version of Log4j? And you know everything.
Yep.
You know what applications, people get, everything, right? And so that's game changing when a 0-day bug comes out, how quickly you can respond.
Yeah, and I mean, this goes, like you just said, APIs and applications as well. And I had a guest last year, and they did this similar thing where they analyzed open source dependencies within your stack. And it's the same scenario. Companies think, oh yeah, we have a couple of hundred, maybe thousands of open source tools, and then when they do an assessment, they realize, oh my god, it's 10 times that much, and nobody obviously cares about them because it's unofficial sometimes, and some of these are not really officially approved things, and then current versions are usually also not in use sometimes. So then this opens lots of questions, lots of issues, lots of security risk problems for a company when there is an old, maybe even a deprecated version in use, and it's like, oh, this is a gate for any hacker, anybody that wants something bad, and it's not good.
Yeah, right. Now, if you have a small team and you're just building kind of one application that's not, a monolithic application, this might be a bit overkill, although the exercise of going through this, like you said, would help find flaws. And I encourage people to do it. In smaller development teams, yeah, you can just pull down data from GitHub or something like that and just scan it and put that in the graph.
Yep.
And you would be able to kind of see some of these challenges. And that's what a lot of these third-party software vendors do that do this. They do this type of analysis behind the scenes. So why not Neo4j customers do this? So we could help or dive deeper into that on another discussion, or if anybody has questions on that, we can dive into it.
Yep.
But I really like this because it solves a lot of problems and creates a great number of clarity, a great increase in clarity. Two other things I'll point out. One, what happens too in these large development corporations, you'll have somebody who goes, I need to write this API. And they'll kind of do a very quick search, I don't know, in the repository, see if there's something there. Maybe they'll spend about 30 seconds. And then they'll say, you know what? I could just code this API myself faster. So they'll go in and they'll write a new API. And because they don't really spend a lot of time doing due diligence, they don't know, well, somebody's written the exact same API.
Yeah.
So now you have duplicate APIs doing the same thing, and which represent double the attack surface for hackers.
Oh, yes.
And double the work, right? You're doubling down the work. So having this visibility prevents that scenario from happening, which is very, very useful. And like I said, troubleshooting too, especially in a large environment, the graph, being able to navigate these dependencies and the connections, really going to be extremely useful. So I think this too is a use case very helpful, especially for the larger enterprises where this is very murky and complex.
Yeah. So comment from Rick, I just read it out quickly, is the shadow API security issue is real. Nice use case. So yeah.
Yeah, the shadow API. Yeah, that's a whole nother one, right? You actually have 2,500 APIs. You think you have 500. That means the other 2,000 are shadow.
Exactly. Yeah.
What happens is people write an API and they say, okay, that's version 1. And now we want to release version 2. We have to keep version 1 running. And then we produce version 2. And then now version 2, everyone migrate to version 2. And we all go to version 2. But guess what happens? Version 1 is still running.
Yes.
It's still there. And we forget about it.
Yeah.
Somebody forgets to go and shut that code down. There's things like that happen. So this use case too is important. And I just highlight this very quickly, that the cybersecurity teams don't always talk to the application development teams. They don't. They're really looking in two opposite directions. And the cybersecurity team could always be playing catch up if the application teams keeps producing these bad, risky APIs. the cybersecurity team will never be able to catch up. So there's this thing called a shift left or shift right, which is, trying to get developers to think more security minded. And that's very important. But conducting an audit, a periodic audit of your APIs, you should do this regardless, because the application teams, as we mentioned, are always under very heavy deadline pressure. And they do take shortcuts sometimes, or they, and so doing this as an audit, a periodic audit, is something I highly recommend. All right, moving right along. This one, unless there's any more questions?
No, not for now.
All right, do you know what spend leakage is?
Also, I can kind of imagine what it means, but maybe you describe what it actually is.
Well, it's money leaking out of your organization, right? It is money being used in a non-optimal fashion.
Mm-hmm.
And again, if you talk to procurement people or chief finance officers, they'll already know, oh yeah, 5 to 10% of our money is just burning away. Like, for example, let's say you bought a subscription to Netflix, and then suddenly you find yourself watching shows exclusively on Apple TV, and yet you're getting billed by Netflix constantly, but you never watch it.
Yeah.
Right. So that's money leaking out of your wallet, isn't it?
It is. Yes.
So same thing happens in the corporate world when you develop these contracts and things like that is, unless you pay very careful attention, things leak out. So here's an example when it comes to procuring things. So this is a chart here. On the left is the total spend by supplier on that axis, and on the right is the number of suppliers that you kind of do business with. And it's broken into three main categories. The first category is your strategic partnerships. So if you're a manufacturer, these are your core suppliers producing components for the products you sell. And so we're looking at total spend for an organization. So up to 60% of what they spend on suppliers fits that category. The other 60 to 80% is what's called tactical spend, and that's when spending on suppliers for expediting things, unique requirements for products, that sort of thing. Okay. These are, tactical spend that you do with strategic or semi-strategic vendors. Okay. And then the third category is called tail spend, and it's kind of a tail because, on a bell curve, right? The tail goes out to infinity. That's where all the other purchases and things are done to keep the company running occur. And so that's where the number of suppliers grows really long. So, you have an employee that bought a laptop from a store, that maybe they did it once. That store is now a supplier, and they've had that one purchase transaction. So if you think about that times all the number of employees, that tail can go really long. And that's the part of the spend that, quite frankly, is not getting enough analysis, not nearly enough analysis. Usually that amount of spend is managed through blanket policies. For example, Neo4j may say, Alexander, you're not allowed to spend more than $200 on a restaurant when you travel, right? So they rely on these blanket policies to protect themselves. But what happens is things change. They never go and look back at those policies and say, do they make sense? That sort of thing. Also, sometimes they'll negotiate with vendors a contract, and the vendor will say, well, if you buy 1,000 laptops from us, we'll give you a 10% reduction, right? But you have to buy 1,000. And so you come to agreement with that vendor, and then again, somebody goes and buys a laptop somewhere else. Guess what? We're losing out on that negotiated contract because that person did something different. So this is where kind of the policies and the contracts start to need to blend together, and they don't, right? So just kind of spending some time analyzing that particular area of the spend can save significant money. And so my Neo4j audience here, I'm going to show you a graph in a second how we could do this, but this could be another low-hanging fruit, right? That we can go after. In this example, you take a customer that's got a total spend of 100 million US dollars a year, just as an example. If we do the 80-20 rule, that means 20 million of that is tail spend, and a 25% reduction in that is $5 million per year. So that's significant. That's real money. Yeah. That could, pay for the license of Neo4j,
Yes.
Right? And that's just that 25% we've seen. I can't provide details, but that's, not that's a conservative number in some cases. So talk to your procurement team and say, would you be interested in building kind of a digital twin of how we're spending money? And maybe I can show you some areas where things aren't working. Mm-hmm. So what we do is we'll take purchase data, purchase order information, which is readily available in your ERP system. We'll take your credit card expense transactions, which are readily available. We'll load them into the graph as a transaction, a merchant, a credit card, purchase item, an employee, and so on. And now we could just run all kinds of queries and analytics against it to find out where it's working and where it's not. And I can guarantee you that this is not really happening today. And so it's a greenfield opportunity for Neo4j customers to go, let me try that. The data is there. Let me pull it in. And I don't think anyone's ever done this before, so let's give it a try. And we could find some interesting things. We look for waste, fraud, and abuse. Mm-hmm. And I hate to say it, we're really looking for waste, but we do, there is fraud and abuse going on.
Okay.
In all companies. Yeah. And we found people doing bad things. Okay. And the way we find it is when we look at the charts, we see a little spike and go, what's that all about? But there's so many questions that we can ask once the data is in this shape to really kind of get our arms around how we're spending, how we classify that spending, who's spending what. And we have some consultants who work with us who are experts in this, who have procurement backgrounds, who've worked for large companies. And we can come in and say, give us 2 weeks and we'll turn the laptop around and we'll show you either waste, fraud, or abuse that we can correct immediately. And just that exercise alone can pay for a lot of things, right?
Yeah.
So I'll pause there. What do you think?
Yeah, that's an interesting one. I haven't thought of this, obviously, but yeah, I mean that's a cool way of analyzing. I mean, with all these, makes sense actually when you think about it. Pattern matching, all of these things you can apply. Graph algorithms, graph data science. You can deduct lots of things out of the data which you have already sitting available to you, and then you realize, maybe, and it doesn't have to be fraudulent, but as you said, it could be. But if it's just wasteful, then it's an interesting exercise. Like you said, could just basically pay for the license by identifying leakage.
Mm-hmm. Yeah, and if anything, it could highlight areas where policies are working or not.
That, yes, yeah.
Right.
Sometimes you think a policy is kind of like helping and guiding, and maybe it's just more doing the opposite.
The seasonality analysis is a dashboard one of our consultants developed, and his hypothesis was that spending on retail, restaurants, travel spike during the holiday period, as well as non-travel related spending.
Okay.
And his theory is like, well, there's a lot of Christmas dinners. There's, you know, people are on vacation, not really paying attention to what's being purchased. And so, yeah, he plotted historical data and did in fact see this seasonality that made no sense other than that it was around Christmas and New Year's Eve. So interesting. And, there's also like PayPal transactions, which is mind-boggling. You find people buying things on PayPal with their corporate card. You're like, what's that all about? Okay, one last use case, global data catalog. So we know what data catalogs are, right? There's plenty of data catalog solutions out there. But did you know that some of these large enterprises have multiple data catalog solutions? It's kind of crazy, right? So we have customers that become awash in data. And so this is supposed to reflect data coming into these data lakes, and it's garbage in, garbage out type thing. Things are moving so fast and furious that you can't keep up.
Yeah.
And this has an impact on our end users where they're like, hey, I need some data. I go to the data lake. I don't even know where to begin. There's just, if I do a search for customer, I'll get 100 hits on tables with the word customer. So in a large company with, especially organizations that have like a research arm, right? Pharmaceutical companies, for example, they'll have lots of people going out there. Their job depends on having the right data, and they'll go somehow procure data on their own. And much like the API world, there's a lot of duplicate efforts, especially with these larger pharma companies, where you have researchers doing all this work and they're not talking to each other. And they're doing duplicate things, or they're using data that is not up to date, but they think it's up to date. And there's a lot of waste and inefficiency here. And an organization that can tighten this up can really make data-driven solutions that much better. So how do we do this? Well, we're going to connect to all these different metadata repositories and build a digital twin of these moving parts in that environment. Data sources, tables, rows, that sort of thing. We're going to take it a step further, and this is what a lot of data catalogs, like tools out there, I won't name names, but they don't do a good job of pulling down ETL or data processing pipeline activity and bringing that into the fold as well. Now, that's important because that gives us an idea of when this data was last updated. And the pipeline, and that's just one node here, but that could actually be several different nodes, because a pipeline can have multiple steps as part of a process. And what happens is often this is done in batch. So the last step in the pipeline runs, and it tells the catalog, hey, we ran at midnight last night. So the user thinks the data is up to date from midnight last night. But what happens is sometimes like step 3 in a 5-step process fails. But step 4 and 5, because they're just running on batch, they're just checking, oh, no new data. I have no new data. They don't know any better, right? So when it gets to step 5, it goes, oh, I have no new data. I'm going to write to my log that I checked last night at midnight, and it worked. My process finished. So because step 3 failed, everyone now thinks the data is up to date, but it's not. It's that type of level of granularity that we look for when we build this kind of global data catalog, to provide our users with that, very clear understanding of when that data was updated.
Cool.
Yeah. Okay. So definitely worth investigating this. So if you have multiple catalogs, and we can this too could be low-hanging fruit. This is an easy graph to build. The data is readily available. Let's go after it, and you'll find like maybe we do have 500 tables that say customer, and no wonder our end users are just going bonkers trying to figure that out.
Yeah.
All right, very quick, last use case, and a quick demo. I know I've been talking along, and I hope this is insightful. But AI, the key component missing in the stack is data quality, right? I know Neo4j does some great stuff with LLMs and RAG and all that.
Yep.
But it's, we're only as good as our data is good, right? So having the ability to combine the knowledge graph with the large language model and the feedback mechanism, which is the third leg in the stool, will allow us to produce some amazing insights and fix problems as they go along. So anyone looking to spend time in building large language model use cases with Neo4j as a knowledge graph and RAG solutions, I'm going to tell you right now, think about that feedback loop that you need to produce better results for your end users. If you don't start doing that now, your project will never get off the ground. Because as soon as somebody uses it and the results are wrong, that's it. They're never gonna use it again, are they?
No. Why not? No, that's good.
Let me show you this in action. So we have this new feature in ProcessTempo called an AI assistant. And I'm going to go into a workspace. Oops, I need to log in first. I guess I timed out. Anybody in the audience wants to have access to this environment, please reach out. In here, it's very easy to spin up a new Neo4j AI and dashboarding environment. So you create a new workspace, you create a new database connector, and if you use Aura or Enterprise Edition, you come in here, put the credentials. What happens is when we create a connection, oh, there we go. I think it failed. It always does in a demo. Here, let's try that. There we go. Okay. I saved that. What happens when you create a connector in ProcessTempo, it starts pulling that metadata on that instance of your graph and storing that in ProcessTempo, and it becomes kind of aware of that. And this is how you can visualize the graph in our Graph Explorer. And if I do a search for, say, product chai, I could see the graph there, right? So I'm running through this pretty quickly, but I can help you connect to the graph, create your own graph experience, and then create your own AI chatbot. And now you could start asking questions of your graph. And this can be done literally in like 5 minutes.
Okay, cool. Oh, very cool.
Right. So in our database, which customers have, I'm just winging this now, purchased and I just know the data. And Nora, the Northwind expert, she's just going to go and generate a Cypher query.
Yeah.
Oh, in this case, of course, she doesn't, but she would generate a Cypher query and go do that. Now, because we're able to link the dashboards, the charts, and the forms, now when Nora does screw up, we can offer some feedback and try to make Nora smarter the next time. And we're running out of time, but I really would love to dive into this maybe in another notes subject about how we can link the 3 legs of the stool together to help get these AI use cases off the ground.
Yeah, I mean that sounds exciting and very interesting. So once we get the call for papers for Notes 2024 open, definitely would be looking forward to your submission to that on that the combination of the 3 parts of the system that I think is a very interesting one.
So yeah, this hour went by really fast.
It did. There's one more question I would like to read out. So I from Nareen that came in. and they ask, because we talked a lot about our digital twins, and they wanted to know, how big do you think is the digital twin market going to be, and how much of it will be powered by knowledge graphs? I mean, can you make a guess, or can you talk a little bit about that? We heard from the top 6 use cases you mentioned, a couple of these were close to being digital twin implementation. So I think is a probably the answer is pretty big, but maybe you have a better understanding.
I think it's more so the digital twin that's driving the growth and investment in graph database technology more so than graph data science, because of that need to understand second, third, fourth level dependencies. That drives a huge amount of demand. I think that's it's a huge market for that. And what I try to talk about with these use cases is that they fit any industry, right? Although supply chain, I talk about, obviously manufacturing, that sort of thing, but these others really fit any industry, and that really opens up the door for the size of this market, doesn't it?
Yeah, it does. I think you when you heard digital twin, you think of, okay, I have this machine, or I have this production plant or whatever, and I digitalize it. But as you mentioned, a software bill of materials, as you wish, is also like a digital twin of your architecture,
Right.
and that is a very valid and very interesting use case. And it's it just, like we said in the beginning, you think of one thing and you think, okay, this is probably very graphy, and then you realize, oh, there is a bunch of other things connected to that, and that also opens it up to more use cases, more applications of the technology. So yeah, it's digital twin is a very interesting aspect, and because of the nature of a graph, how a graph is built, it lends itself very, very easily to be adopted towards that, and to be used in that way, because you have the visual representation of something that is also consisting of parts that are connected to other parts, and that parts could be software, could be machines, could be I don't know, vehicles, could be roads, can be anything, and that works very, very well.
Yeah, totally agree. I really appreciate the opportunity to speak, and I would love the opportunity for Nodes 2024. And yeah, love this Neo4j space, the graph space. I'm very excited for the opportunity for everyone here.
Yeah, cool. Yeah, thank you very much, Phil. One more question. Also would like to know how we could handle streaming data to reflect in the graph real time with regards to being a digital twin. Can you say something to that quickly?
Yeah, the new kind of change data capture features that Neo4j supports, that's big, right?
Yep.
So streaming data with the merge concept would mean I'm not rebuilding the graph from start. I'm streaming data into it using something like Kafka, and it's recognizing whether or not this certain specific node needs to get updated or not. And yeah, in a fast moving environment, that's going to be critical. Um, especially for producing production ready dashboards that we want our executives to see, and we want them to have that, or our supply chain experts to see.
Yeah.
Right.
Yeah. Yeah.
They need to know that they're looking at the freshest data. So yeah, the Neo4j definitely supports that, and that's very handy capability.
That's a very good point. Yeah. Good. Thank you very much for that answer. Thank you very much for attending today, Phil, and for presenting and for showing us these various use cases. I think it was very, very interesting session. Very, very insightful. Very, very good selection. So I mean, like we said in the beginning, don't think of just social networks for graphs. But if you watch this series for a while now, there is a broad usage field to pick from. So I hope you know. But if you don't, then obviously this hopefully showed you a little bit of what can be done. Thank you for watching. Thank you for the questions. Thank you for the comments. And yeah, I'm hoping to see you again next time. if you have, Phil, a presentation ready for notes, and I'm hoping you submit again. The date is not yet set up, so I think we'll have to wait a little bit until we submit that, or we make that public. But hopefully this year for sure. The next session, Neo4j Live, is happening end of January. So next week, no date, but therefore the week after, 2 dates. On the 23rd, we're doing Graph Academy Live. So we're doing a CSV import together with Martin from the Graph Academy team. And on Thursday, we do a interesting session. That's another one from Nodes. Building a semantics-based recommender system for ESG documents. So that's on the 25th of January. Until then, join us on the community, join us in Discord, join us in any way you can. And happy to have you as part of the community. Thank you very much for watching. And yeah, until next time, take care. Bye.